Hi students, this is Srinivas, head of the department in Electrical and Electronics Engineering, Warangal Institute of Technology and Science. Here, our subject control system. In last class, we discussed some transfer function of the mechanical systems as well as electrical system. Already we know that here the mechanical system, there are two types. One is the mechanical translate system, other one is the mechanical rotational system. Next we go for next one is the electrical system. The thing is the difference between the mechanical and electrical systems. Here in electrical system we consider the basic components. The basic elements are resistor, inductor and capacitor. Based on resistor, inductor and capacitor, we apply the Laplace by using the voltage and current equation. We apply the Laplace with the help of KCL, nothing but nodal analysis. That is the electrical system. Okay na? Already ఒక example మనం earlier class లో discuss చేసాం. Here next one is the mechanical system. Here the mechanical systems are two types: mechanical translate system, another one is the mechanical rotational system. Here the thing is the difference between the mechanical translate and rotational system. Here the mechanical system, the basic components are three types. That is the mass, another one is the dashpot, the third one is the spring. Okay na? The thing is the difference between the mechanical rotational and translate system. Here the mechanical translate system, here we consider the displacement with letter X. We are the indicator with letter X. Okay na? Here the elements at the mass, dashpot and spring. Next one is the mechanical rotational system. Instead of displacement, here we consider the angular velocity. With the help of that angular velocity, here instead of force, here the apply the torque. ఓకేనా? మెకానికల్ రొటేషన్ సిస్టంలో షాఫ్ట్ అనేది రొటేట్ అవుతుంది కదా. సో షాఫ్ట్ రొటేట్ అయినప్పుడు ఏమవుతుందండి, టార్క్ అనేది ప్రొడ్యూస్ అవుతుంది. ఇన్స్టెడ్ ఆఫ్ ఫోర్సెస్ హియర్ వి కన్సిడర్ ద టార్క్. దట్ ఈస్ ద డిఫరెన్స్ బిట్వీన్ ద మెకానికల్ ట్రాన్స్లేట్ అండ్ రొటేషనల్ సిస్టమ్. హియర్ ద నెక్స్ట్ వన్ ఈస్ నెక్స్ట్ టాపిక్ ఈస్ ద ట్రాన్స్ఫర్ ఫంక్షన్ ఆఫ్ ది ఆర్మేచర్ కంట్రోల్ DC motor. The transfer function of the armature control DC motor. Here the motor is nothing but already we know that. Okay na? How can we control the speed of the DC motor? DC motor speed ఎలా కంట్రోల్ చేస్తారు? Here the DC motor speed దేనిపై డిపెండ్ అవుతుంది? The speed of the DC motor, here the N is here the directly proportional to the armature voltage, here the inversely proportional to the flux. The speed of the motor here the directly proportional to the armature voltage, inversely proportional to the field winding flux. Okay na? The speed depends on these two things. How can we obtain desired speed? How can we obtain desired speed in a DC motor? Here in DC motor we will obtain the desired speed by varying the armature voltage. By varying the armature voltage we will get the desired speed. Here the field winding flux are the constant. Okay na? Here the analysis purpose or the control of the speed in this control system, we are using electromechanical control system. Okay na? Electromechanical control system. Here in this analysis purpose in electrical system, here the consist of DC motor in the two parts. One is the field winding, other one is the armature winding. Here the analysis purpose we are consider only armature winding. Here the field winding voltage we maintain the excited voltage, maintain the constant voltage. Coming to mechanical system, here we consider the motor to shaft. Okay na? Here the produce the output here with the help of the angular velocity. Okay na? Angular velocity is the theta. Here in order to get the transfer function of the armature control DC motor, in order to get the transfer function armature control DC motor, here we consider the simple circuit. This is the field winding. Next one, this is the armature winding circuit. This is the circuit. For this field winding circuit, here the VF is the field winding voltage. It is maintained the constant voltage. Okay na? Here the field winding resistors and field winding inductor. This is the field winding current IF. Okay. Next one is the coming to armature side. Armature side is the, here the armature voltage is the VA. Here the armature current IA. This is the mechanical output. This is the shaft output. Okay na? For this mechanical output, here the we get the angular displacement. Here the load is moment of inertia and dashpot. Okay na? By using this circuit, by using this armature control DC circuit, DC motor, we will get the transfer function of the system. For in order to get the transfer function of the system, this is the equivalent circuit for the circuit. This is the equivalent armature circuit. In this equivalent armature circuit, here the equivalent armature circuit law, here the armature resistance, here the armature inductance, next one is the back EMF. Motor le emuntadi eppudaina back EMF. This is the applied voltage VA. By using this circuit, we will get the transfer function. Here, analysis of this circuit. Here the RA is nothing but the armature resistance of this circuit. Here the LA is nothing but here the armature inductance. Here the units and the henries. Here the IA is the armature current. Here the VA is the armature voltage. Here the EB is nothing but the back EMF. Here the back EMF of the DC motor is EB is equal to 5Zn by 60 into P by A. Here the same equation for the DC generator and DC motor. DC generator lo induced EMF antaru, DC motor lo back EMF antaru. 5Zn by 60 into P by A. Here the KT is nothing but torque constant. Torque constant. Here the theta is nothing but the angular displacement. Here the shaft rotate anappudu emutundi angular produce avutundi kada, so that is the angular displacement is the theta. Here the J is nothing but moment of inertia. Here the KB is nothing but back EMF constant of the back EMF. These are the terms we used in equivalent circuit or the DC motor circuit, field winding as well as the armature winding circuit. Here, analysis purpose, in order to get the transfer function, we consider the equivalent circuit. For this equivalent circuit, here the apply the loop equation. Loop equation applies to this is the loop. Here the apply the loop equation. Here the armature current IA. The same amount of current is passing through this resistor and this inductance. This is the back EMF. Then total voltage, total armature voltage VA is equal to here the IA RA. Plus here the voltage across the inductor. Earlier used the voltage across the inductor LA into DIA by dt. This is the voltage equation. Here the voltage across the inductor. This is the back EMF is the EB. Back EMF is the EB. This is the equation number 1 by using this equivalent circuit. Okay na? Here output shaft rotate అయినప్పుడు ఏమవుతుంది, టార్క్ అనేది ప్రొడ్యూస్ అవుతుంది కదా. Here the DC motor లో టార్క్ ఎలా ఉంటుంది? Here torque is always directly proportional to the armature current. Okay na? Torque is directly proportional to the armature current. Here the torque TA is directly proportional to the armature current. Here remove the proportional constant, we will get the constant value, that is the KT. That is the proportional constant. KT is nothing but torque constant. KT is nothing but torque constant. This is the electrical system. Okay na? This is the electrical part. Next when we go for the mechanical. So mechanical emunnadi output theta, angular displacement theta, and the load and the moment of inertia and dash part. Moment of inertia and dash part. For this equation, for this mechanical system raskochu J into d square theta by dt square is the moment of inertia. We discussed in earlier. Here the B into d theta by dt. This is the dash part equal to total torque in a output. Okay na? Torque T is equal to raskochu J into d square theta by dt square plus B into d theta by dt equal to T. Okay na? మరి DC motor లో ఏం ప్రొడ్యూస్ అవుతుంది అవుట్పుట్? బ్యాక్ EMF అనేది ప్రొడ్యూస్ అవుతుంది. Here the back EMF is directly proportional to the speed. Directly proportional to the speed. Here the EB is directly proportional to d theta by dt, angular displacement, change of. Okay na? Here the EB is equal to, we remove the proportional constant. The proportional constant remove cheste emutundi. Here the back EMF constant, it is the KB. Back EMF constant is the KB. Okay na? Already we know that the electrical equations as well as the mechanical quantity equations. Okay na? By using this one, by using this 4 equation, for this 4 equation, here the apply the, this is the fourth one, here the apply the Laplace transform. So Laplace applies emutundi. Here the VA, here first the equation Laplace applies emutundi VA. Here the in terms of is converted to S. Here the VA of S equal to IA of S into RA plus it is the first order differential equation. For this first order differential equation in raskochu here the S into LA IA of S. This is the first order differential equation. Same here the apply the Laplace transform. Here the IA of S into RA plus S into LA IA of S plus EB of S. Here the back EMF EB of S. Here that is equal to VA of S. This is the equation number 1. Next, similarly, we go for the torque equation. Torque equation TA of S equal to KT into, it is the constant value KT into IA of S. Here the T of S is equal to KT into IA of S. This is the torque equation, Laplace of torque. Next, we go for the mechanical systems. This is a second order derivation. Second order equation. Here the instead of d square theta by dt here the s square into theta of s and s square into theta of s. J into s square theta of s plus here the b into s theta of s is equal to t of s. That is nothing but torque equation. Okay. Here next we go for the back EMF. Here the EB is equal to KB into dt by dt. And EB of S is equal to KB is the constant. Here the first order derivation, first order equation, here d theta by dt is nothing but S into theta of S. S into theta of S. This is the EB is equal to KB into S into theta of S. These are the Laplace transform of these four equations. Okay now. Next from equation 5 and 6. This is nothing but here T of S is equal to K into IA. Next one is the J into S square theta of S plus BS theta of S is equal to T of S. By using this equation or equate these two equations. ఈ టూ ఈక్వేషన్ ఈక్వేట్ చేస్తే ఏం రాసుకోవచ్చు KT of IA of S is equal to this term. Here the J into S square theta of S plus B into theta of S into S. From this equation, equation we raskochu IA of S raskochu kada. Here from this equation IA of S is equal to raskochu IA of S is equal to J into S square theta of S plus S into B theta of S by KT. This is the equation number 8. Okay. Here from equation number 4. Equation number 4 and the so IA of S ikkada rasam kada. Here substitute this IA of S in this equation. Okay na. Equation substitute chese avutundi here the IA of S or otherwise em chestaru equation ఇంకా సింప్లిఫై చేయాలంటే here the IA of S కామన్ తీయండి. సో IA of S కామన్ తీస్తే ఏమవుతుంది RA plus SLA. here the IA of S కామన్ తీస్తే ఇక్కడ RA plus SLA plus EB of S is equal to VA of S. From equation number 8 and the equation here the IA of S is substituted in this equation. Okay na. ఈ ఈక్వేషన్ లో సబ్స్టిట్యూట్ చేస్తే మనకి ఏమొస్తుందండి here the RA plus SLA into J S square plus BS by KT theta of S plus here the KB S theta of S is equal to VA of S. Okay na. From this equation we will get the transfer function. We will get now to get the transfer function. This is the input. This is the input. But output enti? Output is the theta. Output is the theta. From this equation em raskochu here the transfer function raskochu Laplace of output by Laplace of input kada and theta of S by VA of S. Theta of S by VA of S. From this equation we will get here the KT by RA SLA into J S square BS plus KB KT S from this equation. Okay na. Inka simplify cheyalanunte so multiply these values. Okay na. After multiplying this value we will get the second order equation. Okay na. After getting the second order equation separate the S square terms, S terms and constant terms we will get the finalized transfer function of the armature control DC motor. Otherwise enough for this one. Okay na. Theta of S by VA of S is equal to KT by RA plus SLA into J S square plus BS plus KB KT S. This is the finalized transfer function for the DC motor, armature control DC motor. This is the way of calculation of transfer function for the armature control DC motor. Okay na. Here the next we will go for the same transfer function for the field control DC motor. This is the armature control. Next we will go for the field control. Okay. Here next one is the transfer function of the field control DC motor. Previously armature control is the field control. Here for this field control there is no difference. Here the VF is nothing but here the field voltage. Here the VF is nothing but field voltage. Here the IF is nothing but field current. Here the RF is nothing but field resistance. Here LF is equal to field inductance. Here the kf is the constant. Here already we know that J moment of inertia. Next B is the coefficient or dash part. Okay, now this is the field control of DC motor elements are the main objectives. Here the VF, IF, RF, LF, KF, J, B. And next one is the field current is also there. Here the IF is the field current. IF is the field current. By using this diagram, we draw the equivalent circuit. This is the equivalent circuit. Okay, this for this equivalent circuit. Here the VF field voltage, here the field current IF, RF, here the LF. Here the apply the loop equation. Loop equation apply chesthe enti loop equation apply chesthe we apply the loop equation. We will get here the VF is equal to IF RF plus here the LF, here the DIF by dt. Okay, now this is the equation. Equation number 1. Already we know the torque. Here the torque is directly proportional to the directly proportional to the flux, the current, the field winding current. Here the IF, here the remove the proportional constant, we will get the constant. Here the K into IF. Equation number 2. This is the electrical system. Next one is the mechanical system. For the mechanical system, here the torque T is equal to here the J into d square theta by d theta square plus B into d theta by dt. This is the equation number 3. For these 3 equations, apply the Laplace. Laplace apply the Laplace for 3 equations. Here the VF of S, that is equal to IF of S RF plus here the first order differential. So the first order differential apply here the IF of S into LF. Equation number 4. Okay, now similarly here the T of S is equal to K into or KF and no problem. Here KF into I of S into equation number 5. Okay, now next third one here the T of S is equal to S square J into theta of S. Okay, now this is the second order equation plus S into B into theta of S. Equation number 6. By using this equation 4, 5, 6, these are the Laplace of this 1, 2, 3 equations. Okay, now by using this equation, here the equate equation number 5 and 6. So equation number 5 and 6 equate as KF IF of S equal to here the S square J theta of S plus S into B theta of S. This is the equation number 7. Otherwise, you separate or you write down the I of S is equal to S square J theta of S plus S into B theta of S by here the KF. Equation number 7. Okay, from equation number 6, equation number 6 నుండి ఏం రాసుకోవచ్చు theta of S కామన్ తీసుకోవచ్చు కదా. సో theta of S కామన్ తీస్తే ఏమవుతుంది, సారీ equation number 4. from equation number 4 so I of S కామన్ తీస్తే ఏమవుతుంది, here the VF of S equal to here the IF of S కామన్ తీస్తే here the RF plus here S into LF. Equation number 8. Okay, so from these two equations, equation number 7 and 8, here the equation number 7 equation number 8 రాస్తే ఏమవుతుంది, here the V of S is equal to here the I of S is nothing but రాసుకోవచ్చు S square J theta of S plus S into B into theta of S by, okay na, here the KF by kf into ಏನು ಹಾಸ್ಕೋಚು ఇక్కడ r of rf plus slf. This is the equation number 9 or whatever may be 9. So from this equation ಏನು ಹಾಸ್ಕೋಚು theta of s common తీసుకోవచ్చు కదా. So theta of s common is ಏನು రాసుకోవచ్చు from this equation, you separate the theta of s or common is theta of s. ఓకేనా. సో ఈ ఈక్వేషన్ బేస్ చేసుకొని we will get the transfer function. Transfer function is the output by input కదా. So output is the theta of s. Here the output is the theta of s. Here the input is the v of s. This is the transfer function theta of s by v of s. From this equation, here the theta of s by v of s is nothing but here the v of s and 1 by రాసుకోవచ్చు కదా. So equal to 1 by you separate this one. From this equation we will get the transfer function theta of s by f of s. Here the theta of s by f of s రాసుకోవచ్చు. Here the kf by s into r of f plus slf into b plus sj. This is the finalized transfer function for the field control DC motor. Okay na. This is the transfer function of the field control DC motor. Okay na. The thing is the difference between the field control and armature control. In this field control we are consider the field circuit. Here the armature circuit, armature control DC motor we consider the armature circuit. In that case here the extra term entity, here the extra term is the back EMF in the armature control. In field control there is no back EMF, only we consider the field circuit. This is the field circuit. Okay na. This is the transfer function for the field control DC motor. Okay, thank you.